Yeah. Hello, everyone. A very good evening to one and all. This is Moini Chowdhury welcoming you all on the behalf of CSI VIT. We are inaugurating our new year with the first event of ours by our speaker, Mr. Omkar Pimple. He is an engineering leader, entrepreneur, speaker, and published author experienced with building cutting edge mobile solutions with high performing engineering teams in environments ranging from early stage startups to hyper growth unicorns across banking, learning, and education, health, e commerce, and logistics helped N26 grow into a mobile banking leader by building foundational features such as video KYC, 3D secure authorization, crypto security components, and design systems. So, he is also the founder at Cerebranium, which involves independent mobile strategy consulting and education with a mobile presence reaching 5 million plus users across 180 plus countries in the learning and education space. So, I welcome our speaker, Mr. Omkar Pimple, and over to you, sir.
Thank you, Moini ma'am. That was like a very, very warm welcome from you and everyone at VIT and CSI. So I'm glad to be here. It's always good to be back in academia and kind of, give back all of the experiences and learnings that I've been fortunate enough to gather over the last few years of me being in the industry. So, yeah. So let's get started then. I guess the introductions have been made. So I'm going to share my screen real quickly, and so you can see my presentation. There you go. Okay, just stop me if something's not working here, and then we can retry this. Cool. So hi, I'm Omkar. I'm the founder and managing director at Cerebranium. Cerebranium is a mobile first, AI first, automation first company that is based out here in the EU. I'm currently speaking from Berlin, Germany, and this is where I live for the most part for the last 5-ish years. And today I'll be speaking a bit about how mobile engineering has evolved in the last decade or so, and what things have changed, and how they've changed, and how is mobile engineering and mobile technology being used today to solve very, very real problems. Cool. So let's maybe start this with understanding some of the technologies that you and me and everyone else around us use on a very regular basis, but we don't give too much of a thought about it as much because it's so common. It's so usual to see it around you. It's nothing new anymore, right? But I think as engineers, it makes sense for us to kind of understand how these things came into being. And what is the underlying tech stack and how is the technology that is making these things possible? So maybe we can start with some mobile networks first because like mobility in general focuses a lot on going wireless, right? Because that's what being mobile means. So I think a big part of understanding mobile engineering comes from understanding wireless networks and how these networks are used in real life applications, right? So let's start with Bluetooth. I think most of you, if not all of you, have heard about Bluetooth and have used it in one form or the other, right? So Bluetooth is not something that was discovered or invented in this decade. It has been around since 1989, right? So it was invented by Nils Rydbeck, who was the CTO at Ericsson Mobile, which is headquartered in Sweden. And so back in the day, it was thought of as a replacement for cables. So and as a part of this research, as a part of this ongoing research, the first Bluetooth device was launched 10 years later. So it was invented in 1989, and then it was put into like a consumer device 10 years later. So it took quite some time for us to get it out there, right? And the first Bluetooth mobile phone was a Sony Ericsson phone, but then it was actually another version, a future version of it, the T39, which made it to the stores in 2001. So Bluetooth actually came into consumers' hands in 2001, even though it was worked on and conceptualized and built back in 1989. So that's typically how technology works. Like even if something is on the board or in concept, it takes quite some time for us to actually build it out, test it out, see if it works and solves all our problems that it's meant to solve, and then roll it out to consumers, right? So I think this is a theme that you will see across throughout the presentation today. Yeah, so Bluetooth, what is it exactly, right? So it's basically a wireless standard used for exchanging data between devices over short distances using ultra-high frequency radio waves, right? So high frequency being, so these are low power radio waves. And like I said, it was originally thought of as an alternative to data cables, the RS-232 data cables. And even though it has been around for a long time, it is still going strong. And you have the Bluetooth SIG, special interest group, which is more than 35,000 companies from all of the domains that look at wireless technology as a means. So telecommunication, computing, networking, consumer electronics. So there are 35,000 plus companies from these sectors that form the special interest group that kind of are involved in the development and improvement of Bluetooth. So let's have a quick look at how it's structured. I'm not going to go into too much detail into the architecture itself, but we need to understand here that there are two parts in the Bluetooth architecture. The first part is the lower stack, which describes the core Bluetooth specification. So this includes things like what exactly is the protocol, messaging protocol that you use? What exactly is the payload protocol that you use for packets that you send over from your device to another device via Bluetooth antenna? And that's more or less the lower layer. And then this is where the hardware interfacing actually happens. So with the controllers for the radio interface and the protocols to deal with this interface is what the lower stack is about. And the upper layer stack is focused more on application management, so applications that do use Bluetooth, right? So it does, a large part of it is translating everything that you receive from the radio hardware into something that a Bluetooth application can understand. So again, protocols that do conversion about from one kind of data to another. That's what happens in it happens between the lower and upper layer stack. So you can go into more details over here, but for the scope of this presentation, I'll be leaving it until here, right? I think you might have this in your networking textbooks anyway, so I won't go too much into detail there. Cool. And what are the applications of Bluetooth, right? So I think most of you know that you have Bluetooth in laptops and notebooks and any kind of wireless PC, or even desktops these days have Bluetooth. Mobile phones also have Bluetooth, and I think mobile phones were what Bluetooth was meant for originally. Any kind of wireless device, essentially. You have printers that have Bluetooth, and you can print your papers over Bluetooth these days. You don't need a Wi-Fi network. You have headsets like this one, which I can walk around and go as far back from the screen as I want because it's wireless and Bluetooth is beautiful. You have keyboards and mice and any other peripherals that work with Bluetooth. And again, this is something that changes like the lives of so many people. Like I personally, if you ask me, I do enjoy, like I'd rather have the extra burden of charging an extra wireless device than to deal with the cables, right? But that's just me. But I'm sure a lot of people agree here. Going ahead, you also have wireless PANs. PANs are personal area networks that basically let you create, let's say, your own network where your peripherals are connected, and you can secure it using the right tools. And like, for example, you might want to use it for, Bluetooth triggered lights, for example, right? And you can do this using Wi-Fi, but then you can also do this via Bluetooth. For Wi-Fi, you need a specific router, or you need a special hardware or a piece of hardware for it. With Bluetooth, you can create peer-to-peer networks, right? So ad hoc network creation becomes very easy. So Bluetooth is also something that's used very often with things like, a Fitbit. So a Fitbit will capture information about, your heart rate and how many steps you took and whatnot. And then it uses Bluetooth to transfer all of this information to something like your cell phone, which becomes then like a sensor node, right? So you have a lot of these applications. So you have pacemakers that also use Bluetooth, for example, to transfer information across from one sensor to another sensor node, like a mobile phone in that case. So yeah, the applications are huge, and there's a lot happening in the Bluetooth space. And so speaking of numbers, right? So this is what the device market looks like. So this is in number of units that use Bluetooth. So as you can see, over the last decade, from 2013, it has been steadily, not even steadily, it has been drastically growing, right? So 2013 saw like 1,400, so that's 1.4 billion devices using Bluetooth. And today you have, yeah, almost 8 times that number. So 8.4 billion devices that use Bluetooth. So, and the number is projected to grow, and it's something that has been an emerging trend in the last decade. So, yeah. The next topic that we have is global positioning system. But before that, I'd like to ask if we have any questions from the moderators, and if we do, then we can take them, or else we move on to the next chapter. Okay, no questions then. Sorry, I'm getting notifications. I'm going to mute them real quickly. All right, cool. So the next topic is global positioning system. So that's GPS. We all again take GPS for granted because it has made travel and just getting to places so much easier. But this was conceptualized very early back in the 60s, and then it was actually launched by the United States in 1973. It eventually became fully operational in 1995, but civilians had started to use it. Civilians being people who are not in the military or not in defense, right? So they started using it in the late 80s, right? And back in the day, you had specific modules that could deal with GPS, but now you have phones that use assisted GPS. So this was introduced in 2004 for the first time. And initially, 2004 saw the first successful test, and then eventually we saw phones in the late noughties, so the late 2000s that had phones with GPS in it. So that's basically the history of GPS and how long it has been around for. But what is it? What is it exactly? Like, what is it made of, right? So GPS is basically a satellite-based radio navigation system. So a device relies on the positioning of satellites and its relative positioning with these satellites to understand where exactly on the Earth this device is. And so the GPS network has 24 satellites in the base constellation, being that you can add more to it, but then it has a minimum of 24 satellites in orbit around the Earth that deal with positioning. And a GPS device needs, it needs unobstructed line of sight to 3 or more GPS satellites. So you might have noticed that, sometimes when you're looking at your phone, the accuracy circle that you see on your Google map, it's really huge. So it means that your position that you have is not very accurate because you could be anywhere in this circle. And the clearer view to the sky you have, the better the accuracy becomes of your positioning, right? And the signal strength of GPS is pretty weak. Like if you're indoors, you can't really use GPS for locating where you are. And it's easily blocked by mountains and buildings, right? So that's more or less about how GPS, the overview of GPS is. And maybe this diagram gives you a better understanding of how these things work together. So as a user, you might use a web application or a mobile application that is based on that is a cloud-based application. For example, Google Maps, right? So Google Maps is a cloud-based application which then lets you take in a location fix using the GSM provider and the GPS satellites, and then uses that information to provide value to you. So you can use Google Maps without GPS, but then its value is very limited in that case, right? So GPS changes the way we do applications and what is possible with applications. And this really exploded in the early, at the beginning of this decade. So 2008-9 saw the first, not the first, but a very widespread rollout of GPS devices, mobile phones. And early, like in a few years, like immediately people started thinking of ideas of how GPS could be used to solve real world problems. So speaking of real world problems, these are the applications that Bluetooth has. So of course, the most common one is locations. So finding location fixes for locating positions. And this itself has a lot of sub applications, right? So because you have location positioning, you have easy access to, let's say, roadside support for emergencies, right? It makes it easy for you to navigate to a place that you don't know about this place, and you're traveling and you need to find your way around, and GPS and location tracking makes it really easy for you to understand how you're positioned with respect to the environment around you. So as you can see, hiking and backpacking and solo travels, well, not anymore, but in the last few years, the world saw a boom in solo travels and people who made a living just by traveling. So I think GPS had to do a lot with it because it made it really easy to travel without a map. Because let's face it, like reading a map is pretty hard by itself. Speaking of maps, you have mapping and surveying, which is another application of GPS. So again, mapping involves a lot of measurements of distances, of locations, and all of these things, and understanding how the geographical landscape around an area is. And GPS is used very heavily over there. Tracking for law enforcement. So you might have applications not just for law enforcement, but generally for tracking. So if you use Swiggy for delivery, you take it for granted that you now know where the driver is going to be. But that's because of a GPS transceiver on their device that they now carry and call a phone. Similarly, you can use, it's used in something like Uber, which is basically the same application. It can also be used for locating your pets, right? So pets, can be annoying sometimes and just get lost. That's online, that's cute also, but yeah, it can be difficult to keep track of where they are, especially if it's a cat that loves the outdoors. So you have collars that have GPS transceivers in them, so you can have you know exactly where your cat or dog is if it's lost, and you can track it down. And it can also be used for keeping watch on elderly people, because elderly people often lose track of where they are and what they're doing and why they're doing things, and often it can be problematic. So something like a GPS-based application can help you kind of keep them safe. Another application is treasure hunts. I don't know if any of you have tried these GPS or out in the world treasure hunts, but that's a pretty big application of Bluetooth that's used very effectively commercially also. Apart from that, in business, you have aviation, you have fleet tracking. Aviation is pretty straightforward. Planes use GPS to locate where they are, so they don't land in the water. Fleet tracking is about, for example, if you have a fleet of trucks that are delivering goods across the entire country. Fleet tracking lets you understand and judge better when a delivery might arrive and plan for it accordingly. And of course, hunting, fishing, that kind of goes in the hiking, backpacking bucket of applications. But yeah, the applications are many, and more and more ideas are being thought of and are being used to use GPS and location positioning in real world applications. So that's GPS, and yeah, again with GPS the numbers are increasing. Like right now, the numbers are, I don't know what the numbers are based on this chart, but they're projected to be about $146.4 billion in the next 5 years, right? So the compounded annual growth of the GPS market size in the world is projected to increase by 18.5% from 2018 to 2025. That's pretty huge, right? And it's only going to grow from what we see. And GPS is the US version of positioning. You also have a lot of other countries that have their own navigation systems. Russia has GLONASS, for example, which is supposed to be more accurate, but it hasn't seen widespread adoption yet as much as GPS has. So yeah, that's pretty much about GPS. And as you can see, it has, applications, or the market is in, transport, like on the road, aviation, marine, location-based services. So applications that use location, mapping and surveying and everything else. So yeah, it's a pretty massive way of changing the way we live. Cool. Any questions on GPS? Anything that anyone wants to ask? Okay, cool. Let's move to the next bit then. So the next part is near field communication. So NFC, I guess most of you might have seen or heard about NFC, and you might have even used it in some applications or some places, right? So, or you might have even heard about RFID, which is a very common application. So if you live in Mumbai, you have these metro cards that are used in the metros, which you can just, keep near a sensor, and then the door opens for you if you have enough money in it. So essentially that's RFID, and near field communication is based on that. So basically it's based on technology that allows compatible hardware to supply power and communicate with an otherwise, device that's passive, using radio waves, right? So again, RFID, and RFID in itself isn't something new or relatively new. It has been thought about, and the first patent for it has been granted in 1983, right? So I don't think any of us were born at that time anyway. But yeah, that's a long time ago. And then, but the first consumer device that had NFC came out in 2007. After all of those years, right? So it was a Nokia 6131. I don't know if any of you remember it. I do, but yeah. It was for a consumer trial in the UK, and then 2007 was the year it was launched. And then the first proper NFC capable smartphone, the Nokia C7, was released in 2010, right? So that's a good 27 years after it was first conceptualized that NFC actually came into the lives of consumers. Even then, we didn't truly see a lot of NFC applications. It was just there, The applications truly started coming a bit later, like 2015. You'll see ahead in the next slides about how it skyrocketed. But yeah. But essentially, the way it works is it is a set of communication protocols for communication between electronic devices over a very short distance. Right? So near field communication. And the distance has to be 4 to 5 centimeters or less. It can't be more than that because these are passive devices that depend on radio frequencies to charge them or to power them up also, right? And yeah, essentially it allows compatible hardware to power a passive electronic device or a tag even. And it is an extremely low speed connection, and it is essentially a simple setup that you can then use to kickstart another more secure or more capable wireless connection. Let's take an example, right? So let's think of NFC payments. I don't know how widespread NFC payments are in India, but out here, if I have a credit card on my phone that is authenticated using my fingerprint. I don't have to carry my card or my wallet if I'm paying at a terminal that takes contactless payments, right? So I can use my phone. The phone's NFC transceiver then transmits my credit card information. It is validated using my fingerprint. Then this information is then taken by the terminal, and then a wired or wireless connection to the internet, to payment servers and all of these things is then initialized, and then the payment is carried out. So by itself, NFC did not do the payment, but then it kickstarted the payment. So that's what it can do. It can kickstart, or it can act as a token or an authentication mechanism for very heavy operations that can be then taken care of by more capable devices. So again, the applications here can be huge. But before we go to the applications, let's have a quick look at the architecture. Again, not going to go into too much detail here, but essentially it's a short-range, high-frequency wireless communication protocol. And its operating range is between 106 kbits to 424 kbits per second. And the range is 5 centimeters or lesser than that, right? And it is something that does not consume a lot of power. It is a low power consumption communication protocol. And yeah, essentially you have an NFC controller that has the NFC antenna and deals with the antenna and the hardware of it. And then the host controller is basically the application, is something that interacts with. And then the secure element in this diagram is essentially some sort of a private token that is passed through the NFC antenna to the NFC device that can then do things with it. And yeah, that's more or less how NFC works. And this only works if they're close enough to each other. Cool. So applications that NFC can have, one of the biggest one is identity validation and access control, right? So things like you have these RFID or NFC enabled key cards that you can, that has, let's say, your authentication information on it, and it has your clearance on it. Let's say I work in a building that is a very highly secure building, and I only have access to the first and second floor of a 5-floor building, right? So my key card will open doors on the first and the second floor, but not on the third, fourth, fifth floor. Well, if someone else is maybe the owner of the building and or the owner of the company and has the highest security clearance, their NFC card, which will be the same, but because they have their own identity token in their access card, this can open all the doors in the entire building. So without having specialized hardware, you can kind of have access control checks and identity validation kind of baked in together using NFC. A more closer or more closed kind of application in a day-to-day student life is attendance tracking, right? So again, very similar. You have your token, you have something that you swipe when you enter the classroom, and your attendance is tracked. So that's also an application. Asset identification and tracking. So, for example, when you're sending packages across the entire world, asset identification helps you understand whether your package arrived or not by moving all of those packages near or through something that has an NFC set up around it. So that lets you understand which packages made it, which packages did not. Payments, like I said, is a very big application and has been something that has picked up recently and is growing now. Pairing wirelessly, or at least to kickstart the process of pairing wirelessly, NFC can be used over there. Transportation is also another very good application. This is something that I don't think in India we have it yet, but let's say in Finland, for example, or even in the Netherlands, you have buses and trains and whatnot, and you have your transport card, and you can just swipe it at the entrance, and it lets you in if it's a valid card and if you have enough money in it. If not, then the doors don't open for you. So that takes out the whole ticket vending, operation, which is often expensive at scale. And restaurants and accommodation. So you might have seen in certain hotels, for example, or you might have a key card that lets you only get to a certain floor and not any other floor. So if that key card is for a room on the fifth floor, you can use the lift only to get to the fifth floor and no other floor. And you can use that card only to open that door. So again, using NFC, these are things that you can do. Some stats about NFC. So the market again has been growing very fast in the last decade, more or less. Yeah, again, something like the projected growth of the market is massive because especially with payments, like you see here, from 2012 until 2018, it grew like crazy. So it went from 5 million people using NFC payments in 2012 to 166 million people using NFC for mobile payments, right? So I think that's going to change the way we deal with money and how we pay for things and how we do our transactions. And yeah, so the future scope of this is huge. So that was about mobile networks for the most part, and I'll speak a bit about how the other mediums in mobile evolved over here. But so far, do we have any questions on mobile networks?
Yes, sir. Vedansh Chauhan has a question.
Yes.
So he's asking you, hope you're going to talk about the different versions or the generations of BT.
Different generations of Bluetooth.
Yes, sir.
Yeah, basically the thing that changed with different generations is A, the amount of data it could transfer, B, the amount of power it consumed, and C, how secure it was, right? So the underlying protocol was more or less the same, but all of these improvements kind of came in as with different versions of it. And it's something that is continually being evolved because a lot of these wireless things depend a lot on their hardware counterparts, right? So as we evolve in our hardware, that also changes how we use our networking protocols, right? So that has been the biggest change truly across versions, but the core protocol hasn't changed a lot. I hope that answers Vedansh's
Vedansh.
questions. Yeah.
So we have Naman also who has a question
Mhm.
for you. Doesn't the frequency of Bluetooth interfere with the pacemaker? Naman is asking this question.
Yes, it's a good question, and there are very specific pacemaker. So there are very specific pieces of hardware that are built for each other, so that they don't interfere with each other. So they don't. They are completely different frequency ranges that can still you can use safely with things. So this was something that happened a lot before, and then now the new protocols of Bluetooth let you do these kind of things also. So I don't know. I did not go into too much details on the pacemaker and the health sensor side of things, but yeah, essentially it is something that has been evolving over the years also.
Also,
Cool.
sir, he has
Yeah.
one more question about, doesn't GPS compromise your security and privacy?
Technically, you having a Gmail account has already compromised your privacy. So if you're thinking about privacy while using GPS, it's already too late, right? We'll talk a bit more about that in the later part of this presentation. But essentially, using GPS lets your so essentially the satellite knows that this device is on this location. Now, what that satellite does with that information, only the United States Space Force can answer that question. But yeah, essentially, you're exposing your location to a network of satellites. Yes.
So now we have one final question again by Vedansh. How do wearable devices use GPS through Bluetooth?
So there are different ways of doing it. So, for example, I had a tracker that had assisted GPS, right? What does it mean? It meant that it used the cell phone signal of the GSM signal of my cell phone to get a GPS fix faster, right? So that's what cell phones do also. Like, try it out. Take out your SIM card, turn on GPS, go outdoors. It's going to take considerably longer for you to get a location fix than if you had a SIM card inside, right? So, like for example, this version of the Fitbit 2, I think, yeah. So Fitbit 2 does not have a GPS chip in it, but what it does is it uses Bluetooth on it. It has the Fitbit application on my phone. The Fitbit application uses the GPS transceiver of my phone, uses the Bluetooth channel to transmit the location information to my Fitbit. The Fitbit then takes that into account, takes my heart rate into account if I'm running or biking, whatever else, and then does its computations and all of these things and sends information back to the phone. That's one way of doing it. Another way of doing it is simply the Fitbit keeps sending heart rate information and all of these other specific sensor specific information streams via Bluetooth to my phone, and my phone does all the computation. So either way, like you can couple all of these networks together. So NFC with Bluetooth, Bluetooth with GPS, GPS with NFC. The possibilities are endless. Cool. So yeah, please keep the questions coming, and then we can tackle them at the end of the presentation in more detail and in all of them together. Cool. So that was the first part, the mobile networks part, and the second part is more I don't know how to classify this. Let's just call it how reality has changed with all of the advances in technology, and especially on mobile technology, right? So I guess most of you have heard about VR or virtual reality, or have even tried it out somewhere. I don't know. It has been something that has been catching on lately. But essentially, what is it? It's computer-generated imagery and content that aims at simulating a real presence, through your senses, so sight, hearing, and even touch in a digital 3D environment. So you might have seen these VR goggles or headsets that essentially do this, right? It's completely generated by it's machine-generated environments that you interact with. Again, this is not something that is a new idea. People have been talking about this for decades now, right? So the first commercial virtual reality headsets came out in the mid 90s, and yeah, these were gaming companies that kind of tried VR gaming back then. Of course, we didn't have the right hardware and the right graphics for it back in the day, so I guess it didn't quite take off back then. But then 2016, we had all of these games which had extremely crazy graphics, and we also had hardware to kind of take those graphics and display it, right? So then Facebook, Oculus, Valve, Sony, Samsung, and all of these big dogs, they gathered together and they invested heavily in VR. So this was around 2016. That's also, I think, was when Facebook, I don't remember when Facebook bought Oculus, but when they did, that really changed a lot of things, because it was a very positive, it was a step in the direction that Facebook was going to go into VR, right? And a lot of these other companies also saw the potential in it, and there was a lot of movement around virtual reality in this decade for the most part. So essentially, how do you do it, right? How do you do virtual reality? I'm not going to go into the specific details of creating the environment. That is more specialized, let's say, on the environment design or game design even side of things, and architecture, right? So I don't know if you guys have played Assassin's Creed, but essentially a lot of it comes. You have a lot of common fields of expertise over there. Like the person who architects the game requires a similar skill set as the person who would architect a virtual reality for you to interact with, right? Essentially, it's very similar. But yeah, basically the headset does the job of rendering or showing things to you. And HDMI cables or even wireless these days, it transfers all of this imagery to the screen from a computer of some sort. And you can interact with this reality using various methods. So you can do head tracking. If you move your head around, that's when the reality around you changes. You can use your eyes to, to figure out where you're looking at, and you have eye tracking that lets you change the environment or interact with it. And then there's motion tracking, which captures motion and kind of translates that into an action in um, this virtual reality environment. So yeah, you might have seen some games, people wrecking things and screens and controllers because they got too immersed into the VR game. It's fun to watch it, at least, not to do it maybe, but yeah. But there's still there are quite a few problems with VR also, because people haven't been able to do it for more than, an hour or so. People get vertigo because suddenly what is real and what is not, like the body loses sense of it, right? So like people lose balance, people lose, people lose a sense, people lose a perception a bit of the real world out there, because it's so involved in the whole thing. It can be pretty destabilizing, let's say. So it's still early for VR, but then there's a lot to do over here. So yeah, VR applications, a lot of it has to do with education. So if, let's take an example, right? So you as someone who's studying wildlife maybe cannot go directly to, where rare animals live. But if you have video footage that has been, let's say, created in a virtual reality environment, you can walk into that wild animal's home or world or reality, right? Virtually. So, and study it better and so on. So education is just one field, but this is just beginning. There's a lot to be done over there. Visualizing scientific and research data, right? So understanding, of course, visuals are a lot more easy to understand than a lot of text. So, but visualizing this and interacting with this is completely a different ball game, right? Monitoring, training, diagnosis in medicine. I think this one is a very exciting one. There's like, imagine you're studying surgery, right? And they're not going to let you near real body anytime soon, right? But how do you then learn how to, I don't know, how to open up a body and transplant hearts, right? So with VR, maybe you might be able to do it in the near future. I don't think we have this yet. This is still in experimentation, but it is a possibility that is being talked about and that is being worked on. Industrial design and architecture, like we spoke about before, like if you're building Rome as it was, I don't know, in the 16th century, you can build it out in VR and really live the life of a 16th century peasant in Rome. So, whatever makes you happy. Gaming and entertainment. This one is a big one, of course. It started, I think, VR started with gaming and entertainment, and then it went beyond to all these other industrial applications. Yeah, so right from video games to, I don't know, everything else, like videos, movies, adult videos even are in VR these days. So yeah, there's a lot on the gaming and entertainment side that is being done on VR. So yeah, that word is VR. And VR has a cousin called AR, augmented reality, right? So augmented reality, the main difference, which we'll talk about more in detail ahead, but augmented reality is augmenting your existing reality, right? So you enhance parts of the user's physical world with computer generated input, right? So it can be as simple as these annoying dog ears that you see on Snapchat, right? That's the simplest form of AR. And it's digital content which responds in real time to change in the user's environment. So it recognizes, a person's face, a person's nose, a person's ears, a person's whatever else, and then it transforms or augments that reality using with computer generated input on that reality. So again, this is not something that is a new idea. People have been thinking and talking about this for, again, decades, right? 1968. Yeah. So the first head-mounted display was created back then. There's sort of Democles. So it's been talked about for a long time. The term AR itself was coined in 1990 by Boeing engineer Tom Caudell. And then the first AR game, AR Quick, was launched in 2000. So it involved a head-mounted display, and it involved the backpack, which had a computer and gyroscopes to track motion and movement. So yeah, of course, I guess it didn't go much further from there, but then you had a lot of games that came out. For example, AR Tennis, which was a multiplayer AR game for the Nokia phones, which came out in 2005. But right now, with artificial intelligence and all of these things, AR is really, really, really catching on. Like you see it almost everywhere. You see Amazon telling you how a piece of furniture will look in your apartment by just pointing a camera at that place. It will tell you if this piece of furniture will fit in the corner that you have or not. It'll tell you how it will look. It will tell you, all of these things, which is incredible if you think about it. And there are walk-in apartment viewings now. If you want to move into a new apartment, you have AR, VR, both are used over there to kind of have walk-in experiences into apartments. So this was something that we were thinking about in 2015, 2014 and 15. So I was working for a company called housing.com. I don't know if you guys know about it. It was very famous back in the day for many reasons, but one of the things that we were exploring back then was this, like VR headsets, so that people don't have to go to an apartment to actually view it. They can walk through an apartment virtually and understand how it feels to be in that apartment. Of course, it was too early for that kind of technology and that kind of mindset also. And of course, it didn't go anywhere there. But it was still a cool idea to work on and try out and just think about. So that's augmented reality. And essentially, the concept is, like I said, there's an input from a camera or like an input from the real world, let's say, or another input device like glasses, smart glasses, right? So which creates an illusion in the real world. And then to create this illusion in the real world, you overlay it with input from, let's say, your algorithms. So input from the real world from hardware, like from camera, and input from an algorithm to create a new reality that augments the real reality, whatever that means at this point. So there are three approaches mainly that you can do. So there's recognition-based augmented reality. So understanding what objects you have in the frame, like Snapchat ears, for example. Location-based. So a friend of mine and a colleague of my ex-colleague of mine, he has an app called The World Around Me, right? So what this app does is you can point this app anywhere you want, and it will tell you on the screen all the places that will be there in that direction in your world and how far they are from where you are right now. And if you're traveling, this is great because if you're hunting for a coffee, you just open this app, you're like, okay, I need a coffee place close by. And it'll tell you that, move left, there's a coffee place, keep walking here, you'll find it. So that's location-based. And SLAM, or SLAM, is simultaneous localization and mapping. So this is where robots are used, which kind of, survey an area and then simultaneously create an augmented reality based on the information that they capture of that area. So there are multiple more, but then these are the main categories of how AR is approached. And of course, the applications for AR are many. You have medical training, again, like we spoke about before with VR. Repair, maintenance, design, modeling, tourism, like we spoke about right now. Classroom education, entertainment, public safety, by including, let's say, another layer of visuals or graphics or helpful pointers or whatever else. You can say that, what, don't go there because, I don't know, there's a leopard over there and the leopard killed 50 people. These are the headlines and you see them right in front of your eyes and you won't go there, right? But people still would anyway, and that's why the headlines come through. But yeah, you can use applications can include informational to entertainment, right? So it can be used in a lot of places. It's still nascent. I would say there's a lot of work that is being done here, and there's a lot more to do here. So definitely, especially on the education training side, there's quite a few things to be done here. So it's an ongoing field. And the main difference between virtual reality and augmented reality is, yeah, virtual reality is a completely immersive environment, and augmented reality is uses your existing reality and then adds more things to it, right? Uh, in virtual reality, visual senses are under the full control of the system, right? So you don't know if you're, when you have the VR headset, you don't know if you're 2 steps away from falling off a 15-story building, right? But in augmented reality, you would have that sense of presence in the real world. Um, Apparently, VR requires at least 50 megabytes. I saw this on the internet, so I put this here, right? I don't have much to say about this, but AR requires 100 plus Mbps. For VR, you need an actual VR headset. Of course, for AR, you can use more commonplace devices like phones, for example, or your computers. So that's more or less the main difference between VR and AR. Cool. So before we move on to the next chapter, let's say, does anyone have any questions here?
It's not a question though, but again, we have Vedansh Chauhan talking about a different app called as Just a Line by Google,
Mm-hmm.
which in layman's language is like let's draw in air using gyro.
Right,
So he had a add-on on what you were
right,
just sharing.
exactly. So classic AR, uh, AR being put to use, on the entertainment, perhaps on the training side. So yeah, lots of applications over there that you can do. Did any of you guys play the Pokemon game? I forgot the name. Pokemon Go, was it? Yeah.
Yes, yes, Pokemon Go. Do let
Right.
us know in the comments below if yes, do comment yes.
Yes. Well, I didn't play it, but I guess I was, it came out too late for me. But yeah, that's again an AR application on the entertainment and location-based AR application, right? Because it completely focused on where you are, and your Pokemon came out based on where you are and what time and all of these things. But yeah, AR VR is really fun, and there's a lot to do there. Cool. All right, let's move on then, and then right. So now that we've kind of understood how technology has evolved and was born at the time, but then has evolved very drastically in the last 10 years, how about now? Right now, in the last 6 months, the world has changed. Like nobody who's alive today has seen anything like this, right? So in today's world, like what are the biggest problems that we have? So the biggest problem that we have is COVID-19 is it's very infectious, so it has a very high degree of infectivity, and it has a relatively long illness window, right? So 14 days, potentially someone being sick for 14 days and occupying a hospital bed for 14 days, it creates a lot of traffic in healthcare systems, so hospitals or emergency rooms, which already, had, let's say, capacity issues. And of course, something like this, where everyone's exposed and at risk, um, like creates a traffic jam onto our most vulnerable points in the ecosystem that we live in. So that's a very big problem. And the second thing is that because of this problem, we as a society need to be able to quickly identify potentially infected individuals, right? So that you can avoid this traffic jam, so that other people who require all of that care get it on time, right? And the third part is because it's so highly infectious, you need to be able to trace the chain of infection in order to contain it. Because the only way to slow, um, let's say, the amount of infection, or to alleviate the pressure on healthcare systems, is to slow the amount of infections. And to slow the amount of infections, you need to be able to trace the chain of infection in order to contain it. So these are the three big problems that we have today, right? So how has mobile engineering helped us in the COVID-19 era, right? So you might have heard of contact tracing. I don't know. Most of you might have heard about it. You might have heard about Arogya Setu and all of these apps. And essentially, they use something called contact tracing, right? So the basis of contact tracing is that each device, right? Each device, it regularly broadcasts a device ID of some sort. It's a pseudonym, or it's a unique ID, let's call it. And each device regularly broadcasts its device ID, which we can call chirps, just like birds do, right? And each device also periodically monitors the chirps from other devices, right? And the distances of these devices is based on signal strength. So basically you're mapping how strong the signal is from another device to how far that device is from your device, right? Because signal strength is proportional to the distance. And so what happens now is that when the owner of a device identifies themselves as COVID positive, so let's say device, I have another diagram which we'll talk about more detail over here. But basically the way it works is whenever the owner of a device identifies themselves as COVID positive, all the devices that were around this device are alerted for potential exposure. So that's how we know that, given that mobile phones and people are inseparable at this point, we know that if a device was close to another device, it is possible that the person who owns that device was close to the person who owns the other device, and potentially they were close enough for potential exposure. So that's essentially the basis of contact tracing, right? How does it help? So it helps by interrupting ongoing transmission and alerting people, for any risk exposure, and ensures that people who might not have been infected yet can still be protected. And people who have been infected already, you can already offer diagnosis, counseling, and treatment, and also to understand epidemiology of a disease in a particular population, like how it spreads, how many people who came in close contact with each other tested positive, how many did not, all of these things. Right. So Bluetooth and GPS are the technologies that we use for contact tracing, right? So why though? Like what about Bluetooth and GPS does it make it so useful for things like this? So GPS location data is analyzed for movements in large groups, right? So for example, on Google Maps, you're able to see the traffic. So Google is able to tell you, okay, this road is super congested because there are 100 devices that are stuck there and have an average speed of whatever, 10 meters per second. There was an experiment done by a dude. I don't remember where, but then what this person did was he took a little hand cart, he put 100 devices and he turned on Google Maps in all of these devices. So basically he had 100 devices in a small area and he dragged it slowly across the street. So Google servers were tricked into believing that there were 100 cars or 100 drivers stuck on that street, and it showed like a red line on that street. So basically, GPS location data is analyzed for movement in large groups so that you can predict or analyze or recommend, let's say, things based on it. So that's one reason why GPS is useful for contact tracing. The second part is periodic monitoring of the chirps from other devices. Like I said, is based on signal strength, right? So if the signal strength is really strong or really high, the device is much closer than, let's say, the signal strength is very low, in which case the device is further away. And then you can come up with a formula for this, signal strength and distance. And essentially, because Bluetooth uses low energy radio signals, which can work up to, let's say, a meter to 10 meters. you know exactly that, when the signal strength is high enough, so that probability is that this person is between, let's say, 2 meters, which is the COVID distance, let's say. That's how you understand that, two devices or two people were potentially exposed to each other if one of them was COVID positive. So now, based on this, what happened was Apple and Google, they came together, which, it's like hell freezing over. They came together and they worked together to create something called as an exposure notification framework. So for people who build mobile apps or have tried mobile apps, the framework, the Android or iOS frameworks, they let you use this exposure notification framework. So you don't get to see the actual data that is being transferred by these devices, but you get to use tokenized information around it, right? So cryptography is used over here because you want to preserve privacy. So the person who asked the privacy question, this is where we're leading now, right? Because location data can be extremely sensitive. Health data, because we're talking about health over here, right? So people who have been diagnosed positive, they need not want, or they might not want to be willing to broadcast this information to everyone, right? So yeah, it's pretty straightforward. And basically this cryptography layer, it adds an extra layer of security. So the apps that use this exposure notification framework, they themselves can't even see the raw data that is being passed around. And even apparently, according to Google and Apple, even Apple and Google don't have access to this information directly. But instead, this protocol will be accessible to public health agencies for dealing with the COVID crisis using an API called Exposure Notification API that will allow these apps to log and receive data. So that's basically the ENF, the Apple Google Contact Tracing Framework, Exposure Notification Framework, right? And it was released in 2 phases, but basically I'm not going to go into those details. But essentially, the way it works is this, right? So classic Alice and Bob situation. So let's say they meet each other for the first time and talk for a bit. When they do, their phones exchange anonymous beacons, or let's say identifiers, right? And these identifiers also rotate frequently, which means that if you happen to, get your hands on an identifier, you might not be able to find which device this identifier belongs to because it might have changed by then. So it reduces the risk of this tracking. Now, let's say a few days later, Bob is positively diagnosed for COVID-19, and let's say he informs in the app saying that, yeah, he's positive. And then in that case, what happens is then Bob, with his consent, of course, his phone uploads the last 14 days of keys for his broadcast beacons to the cloud. So his own keys that were generated over the last 14 days, they're uploaded to the cloud. And on Alice's side, she doesn't even realize that something like this happened, right? So, but her phone periodically downloads all of the keys that were COVID positive, let's say. And then locally on that device, the comparison happens, right? So it downloads all of the keys that in her region that were tested or that were marked as positive. And then her device compares and and checks if she encountered a key that was marked as COVID positive on the cloud. And in this case, Bob, she met Bob and Bob was positive, and therefore she sees a notification on her phone saying that, yeah, she was close to someone who was tested positive recently, so maybe she should take precautions also, and there's more information on what to do next. So that's how the whole contact tracing system works together. And then that takes us to the next topic of privacy. So how do you ensure privacy of sensitive information, your location, your health information, and all of these things? So Apple and Google, the exposure notification framework. So the security and privacy, let's say, guidelines and protocols are these. So basically, location is optional, and it is opt-in based. So I have to opt in and to provide my location, and the system still works without location, right? No other personally identifiable information, PII, is collected, so it's completely anonymous. And like I said, device identifiers are changed every 15 minutes to reduce the likelihood of location tracking via Bluetooth. So even if you get your hands on, let's say, an identifier, you still wouldn't know which device this belongs to. The processing happens on the device itself. So the list of people you've been in contact with never leaves your phone, right? So it never goes to a central server. It is up to the user to decide if they want to contribute to contact tracing. So there's the consent and opt-in based mechanism. And COVID-19 positive users must consent to sharing their diagnosis keys with the server. So again, there's a layer of consent over there also. And the data itself is protected from Apple, Google, and other third parties. And this is the only part that I personally think is fishy, because it will only be used for contact tracing by public health authorities. And call me a cynic, but then it's like, yeah, if it'll be protected from Apple, Google, and other third parties, except for this one third party, which we call the state, that doesn't quite compute for me. But that's just me, right? But overall, it looks like a pretty solid, framework for privacy protection, and that's one of the reasons why this was introduced by Apple and Google, because there was a need to do so. Now, there are two approaches to it, right? So what we saw from Apple and Google was a decentralized approach. A decentralized approach is one where all the processing happens on each device. It's not centralized on a server, right? Comparison happens on each device by downloading the device IDs from a server. Now, on the centralized side, what happens is the contact test, the first two steps are the same, but then afterwards, each device uploads all of the device IDs that it contacted and the location potentially to a central server. And then there's an algorithmic analysis that's carried out on the server to send out alerts to people who might have been exposed, right? So of course, a centralized approach is where the privacy concerns come in a lot more, because, yeah, a third-party server has all of this information about who you met, where you met them, when you met them, and so on, right? So one of the reasons why Apple and Google came out with the ENF was because some countries like India, for example, went for the centralized approach, which had huge privacy concerns. And that's one of the reasons why the decentralized approach was introduced, and was introduced as a framework, as a part of the Apple and Google framework, mobile framework. So it's an API that can be used. You don't have to build it from scratch. And the countries that took these two approaches, so for example, the centralized approach was adopted by France, South Korea, Poland, Portugal, Israel, India, and UK, who then abandoned it because nobody used it. But the decentralized approach was adopted by Germany, US, Italy, Switzerland, Canada, and Spain. And essentially, these countries use the ENF protocol because Apple and Google built it exactly for that purpose. So yeah, that's more or less how the whole GPS, Bluetooth, and all of these things play into privacy in today's world in the COVID-19, era. And yes, there are concerns. Yes, there are, things that we should be worried about. But definitely, we can see that mobile engineering is something that is super powerful, and there's a lot that's happening on the mobile front, right? So right from entertainment to education to health, to tracking your vitals, to just payments and everything that you do on a day-to-day that you used to do before without mobile phones, now you can do on phones. And imagine if COVID-19 broke out 20 years ago, 15 years ago, we wouldn't be able to build contact tracing the way we did right now. So definitely, I think it's a testament to how powerful the mobile platform is and how nascent it still is. I mean, it's been around for quite a while now, but it's still only beginning, right? And we at Cerebranium, we have, we bet on the same. And I personally have been in mobile engineering for about 8 years now, so almost a decade. And it's still going strong, and it's only going stronger, right? So we at Cerebranium, we believe in the same, and we're using mobile engineering for education tech, for health tech also. And I come from a fintech background, so I built a mobile bank in the past. So, like I said, there's a lot to do here, and Cerebranium is also looking in the same direction, and we're building out a lot of mobile first, AI first things. So, if you're interested in what we do and you'd like to check us out, this is our website. We have a team of mobile engineers and machine learning engineers, and who work on very cutting edge technology. So yeah, check us out. And yeah, that's it for today. And let's maybe have questions now. No questions?
No, sir, there are questions.
Hmm.
One question is, a few months back, Airtel launched Wi-Fi calling in India. How
Hmm.
does the Wi-Fi calling system actually work?
Good question. I'm not very sure how that works. I haven't been in India, so I don't have the context of what's happening out there as much. But essentially, this might be completely wrong, right? And I'm on stream, but I'm still taking a risk here. It might be very similar to how WhatsApp calling works, but that's the only information that I have on it now. I don't know much about what Airtel's doing in India, unfortunately. Sorry. Any other questions?
Yes, sir. So there's one more. Can a contact tracing app be used as a surveillance system if a centralized approach is used?
Yes, it can be, and that's what the biggest privacy concern is, right? That what is a surveillance system in the end, right? So in China, for example, they also use surveillance cameras. So using face detection, contact tracing, location, all together. So they exactly know which person met which other person, which one of these is COVID positive, when they met, what location they met. It's crazy, right? I don't think a government should be as powerful um, to do these things. So to answer your question, yes, it is possible, and that's why we should be very mindful of these things as someone, as people who understand technology. Any other questions?
No, sir. These were the questions that were asked, and you answered them.
Okay, cool. All right, great. So thank you all for listening. I hope I did not bore you too much. Um, that was Omkar from Cerebranium. And yeah, I guess I'll see you sometime later again, perhaps. See you and stay safe, all of you.
I would like to thank Omkar sir for such an interactive event, and I would also want to remind you all to fill the feedback form. Thank you so much again. We are ending the session.